Deep beneath the Earth's surface, where crushing pressure and unbearable heat have shaped carbon into crystals for billions of years, the story of a diamond begins long before it ever reaches a jeweler's hands. But the true transformation, the moment when a jagged stone becomes a symbol of luxury, happens inside modern processing facilities that operate with the precision of laboratories and the intensity of industrial powerhouses. This journey from raw mineral to polished gem is a complex choreography of science, engineering, and human expertise, a process that demands flawless execution at every stage. Many people imagine diamonds arriving from mines already sparkling, but the reality is far more rugged. Rough stones are irregular, opaque, and often mixed with impurities. They bear the marks of their violent creation deep within volcanic rock. When these unpolished fragments enter the processing line, they are first subjected to a meticulous classification routine that sorts them by size, color, clarity, and potential yield. Specialists examine each stone under bright clinical lighting, searching for hidden internal fractures or subtle distortions that will determine its fate. This moment is critical. A single wrong assessment can mean thousands of dollars lost in potential value, since cutting the wrong angle or misreading a natural inclusion can destroy a stone's brilliance forever. Once categorized, the diamonds enter a higher level of scrutiny, where advanced imaging systems map their internal structure with microscopic accuracy. Using 3D modeling software, technicians simulate dozens of possible cutting plans to discover which one produces the maximum combination of carat weight and visual quality. This stage blends the analytical discipline of engineering with the artistic judgment of a master craftsman. Every decision is calculated, because each stone has only one chance to be cut. There is no undo button, no second attempt. The processors must predict how light will eventually travel through every facet before a single blade touches the surface. The pressure to get it right is immense, and it sets the tone for all the steps that follow. While the early stages may seem clinical, there is a quiet tension in the air. These facilities handle stones worth millions collectively, and even the smallest error during evaluation can echo through the entire production chain. The transformation from rough to gem begins not with cutting, but with foresight, anticipating how a lifeless stone could one day refract light with a signature fire. In these initial rooms filled with the hum of machinery and the steady rhythm of appraisal, the foundation of brilliance is set. What happens next is a mix of precision engineering and delicate craftsmanship, where technology and human skill come together to unlock the hidden potential inside every rough diamond. Before a diamond can be shaped, its internal world must be decoded with absolute precision. Inside processing centers, this stage resembles a fusion of medical imaging and high-level industrial design. Each rough stone is scanned using laser tomography and high-resolution microscopy capable of exposing every flaw, feather, cloud, and microscopic crack hidden beneath the surface. What appears to be a solid crystal to the naked eye often reveals a landscape of intricate irregularities. Tiny stress lines, mineral inclusions, or ancient fractures formed during its violent ascent from deep earth. These imperfections are not merely cosmetic, they dictate the exact strategy that cutters must follow. A single microfracture can redirect the force of a blade and split the stone in an unintended direction, turning a high-value diamond into a pile of unusable shards. That is why the mapping phase is treated as an operation of absolute stakes. Once the full internal blueprint is generated, the data flows into sophisticated 3D modeling programs. Here, the stone is virtually rotated, sliced, and reshaped dozens of times in simulated space. Each simulation calculates how much carat weight will be preserved, how symmetrical the final design will appear, and how efficiently light could be reflected after polishing. Engineers examine potential cuts from every angle, crafting a digital pathway that maximizes both beauty and commercial value. It's a relentless game of optimization. Preserve more mass or enhance brilliance. Aim for a classic round cut or a specialty shape that saves more material. Every rough diamond demands its own tailored strategy. Nothing is generic, nothing is predetermined. The chosen cutting plan becomes the operational blueprint, and technicians mark the stone with laser-etched guidelines that indicate where splits, cleaves, and facet alignments will occur. These markings form a map of future brilliance, outlining the precise geometry that will eventually unlock the diamond's fire. At this moment, the rough stone stops being a random mineral and begins transitioning into a controlled engineering project. The facility's environment shifts as well. Bright ergonomic work lights illuminate each workstation, and the background noise softens into the steady hum of laser machines warming up for the next phase. Despite the heavy use of technology, the atmosphere is far from robotic. There is an unspoken awareness of the value resting on every table. Workers move carefully, almost deliberately, knowing that the tiniest vibration during marking or scanning can throw off the alignment of an entire cutting plan. Here, science and precision form a fragile partnership. One miscalibrated laser or misinterpreted internal reflection, can ruin weeks of preparation, and yet when the process succeeds, the transformation feels almost surgical. Every line etched on the stone carries the promise of a gem waiting to emerge, and the facility becomes a place where geometry and geology merge into a single mission, shaping the perfect cut. With the cutting plan finalized and every guideline etched with micrometric precision, the diamond arrives at one of the most dramatic stages of its transformation, the cleaving and sawing phase. This is where the rough stone finally encounters force controlled, calculated, and backed by generations d'experimentation. Despite advances in technology, this moment still carries a tension that no machine can fully eliminate. One wrong angle, one vibration, or a misaligned beam can compromise the entire stone. The initial split is the irreversible threshold, where planning and prediction give way to execution, and the rough diamond begins revealing its future form. To begin, technicians secure the stone into a specialized clamp designed to eliminate micro-movements. Even a fraction of a millimeter of instability could redirect energy through an unintended path within the crystal lattice. Depending on the stone's structure, the cutter might use a laser beam, thin as a hair and hot enough to vaporize carbon, or a traditional diamond-coated saw spinning at thousands of revolutions per minute. Laser cutting is often preferred for its accuracy, allowing operators to slice along predetermined lines with minimal heat dispersion. Still, the process isn't as simple as tracing a line. Diamonds are incredibly hard but also brittle along natural cleavage planes. The cutter must respect the stone's internal architecture, applying force only in ways that align with its formation. Otherwise, the crystal can fracture unpredictably, destroying months of mining and planning. When the moment comes to make the first cut, the room's energy shifts. The machines emit a steady whisper, and the workstation lights narrow into focused beams, illuminating only the stone and the technician's hands. The laser moves slowly at first, scoring the surface layer by layer, until it penetrates deep enough to guide the eventual separation. For stones that require traditional cleaving, a precise groove is scored manually, and a thin steel blade delivers a controlled strike, an old technique still used because it respects the diamond's natural planes better than modern tools in certain scenarios. Whether high-tech or traditional, this step is an orchestration of accuracy. There is no spare diamond, no second chance. Once the stone separates into its intended segments, each piece is examined again under magnification. Technicians inspect the split surfaces to ensure the crystal behaved exactly as predicted. Clean separations affirm the success of the mapping phase, while unexpected ripples or micro-cracks require adjustments to the next stages of sawing and shaping. At this point, the large rough pieces begin to resemble the outline of future gemstones. Some fragments will become centerpieces for jewelry, others will be polished into side stones or smaller cuts. Regardless of their destination, every piece enters the next phase with a clear structural purpose. The aftermath of this first break is a quiet validation of science and craft working in harmony. The raw opaque mineral that arrived from deep earth has now begun its evolution into geometry, still far from the brilliance we associate with diamonds, but undeniably on its way. What follows is an equally demanding process where each fragment is sculpted, refined, and gradually shaped to capture light rather than merely withstand it. After the rough stone is divided into workable pieces, each fragment enters a phase where its future identity is carved with mathematical discipline. This is the stage where the diamond transitions from a broken crystal to a structured object designed to manipulate light. Known in the trade as brooding and preforming, this part of the process is less glamorous than polishing, but without it, no diamond would ever achieve the symmetry that makes it valuable. Here, technicians reshape each piece into an early version of the gem it's destined to become, establishing the proportions, angles, and silhouette that will one day govern how brilliance and fire emerge. The first technique applied is brooding, the step where the diamond is rounded and given its basic outline. Traditionally, this was done by rubbing one diamond against another, exploiting the fact that only a diamond can cut a diamond. Modern facilities refine this method through high-speed rotary machines fitted with diamond-encrusted wheels. The fragment is fixed into a rotating holder while another diamond piece presses against it, slowly grinding the stone into a symmetrical circular shape. Every rotation must remain stable. Even a slight wobble can distort the girdle, the outer edge of the future gem, and compromise the optical performance of the final cut. As the stone spins, technicians monitor the contour with a jeweler's loupe, adjusting pressure and angle with expert sensitivity. Once the general outline is established, the diamond moves into preforming. This is where the stone begins acquiring recognizable geometry. Flat planes are introduced, early facets are sketched, and the stone's overall structure is refined. Lasers and grinding wheels mark the main crown and pavilion angles, acting as a skeleton that later faceting will complete. The goal isn't beauty yet, it's architecture. Preforming determines how many facets the final gem can support, how deeply light will travel inside it, and how efficiently that light will bounce back to the viewer. If brooding shapes the diamond's body, preforming defines its posture. The atmosphere in the preforming area is a mix of intense concentration and rhythmic machine noise. Sparks fly as diamond dust scatters across the workstation, a byproduct so valuable that facilities collect it for industrial use. The technician periodically pauses to examine the developing shape under magnification, ensuring the angles align with the digital blueprint established earlier. Any misalignment at this stage will echo into the final product, producing a gem that's technically polished but visually dull. The challenge is maintaining perfect symmetry while removing as little material as possible. Every fraction of a carat preserved increases the stone's final market value. Despite the noise and mechanical precision, there is a human element that machines cannot replace. Experienced cutters develop a feel for the resistance of the stone, a subtle feedback through the fingertips that tells them whether they're following the crystal's natural structure or pressuring it in a direction that risks microfracturing. The partnership between human instinct and engineered tools is crucial here. One provides consistency, the other intuition. Inside these workshops, the diamond ceases to be a raw geological artifact and begins evolving into a calculated creation. Its proportions start to form, its symmetry develops, and its potential brilliance is set in motion. By the time a stone leaves the preforming station, the foundations of its final character are set. It doesn't sparkle yet, but its future brilliance is embedded in every aligned angle and carefully shaped curve. What comes next is where the diamond truly earns its identity, an intricate, painstaking dance of crafting facets that transform geometry into light. When a diamond reaches the faceting stage, it finally enters the territory where mathematics and light collide. Everything up to this point has been preparation, crucial, precise, and foundational, but faceting is where the stone begins to justify its reputation. This is the moment when a dull, chalky crystal starts catching glimmers of the radiance people associate with luxury and permanence. Faceting is the process of sculpting dozens of tiny, flat surfaces across the stone's crown and pavilion, each one strategically angled to capture light, redirect it, and release it in a burst of brilliance. No part of the process demands more finesse, because these microsurfaces must align with microscopic accuracy to avoid light leakage and dull reflections. Each diamond is fixed onto a dop stick, a slim metal arm that holds the stone steady in a specialized faceting machine. Using a template derived from the earlier 3D mapping, the technician adjusts the dop to precise angles, rotating and lowering it so each facet meets the polishing wheel at the correct orientation. The wheel, charged with diamond powder, is the only material capable of shaping the stone without damaging it. As the technician makes contact, the wheel shaves away microns of carbon at a time. The process is slow, detailed, and incredibly demanding. Even a deviation of half a degree can alter brilliance and symmetry, reducing the stone's overall value. Faceting follows a strict order, beginning with the main facets that define the diamond's structural balance. On a standard round brilliant cut, this includes establishing the 8 main crown facets and 8 pavilion facets. These broad surfaces create the framework that determines how the remaining smaller facets will interact with incoming light. Once these major planes are in place, the cutter introduces secondary facets, minute surfaces that refine the geometry, increase light return, and sharpen the overall scintillation. As the number of facets increases, the stone gradually develops its signature pattern of flashes and reflections. What starts as faint glimmers becomes a vibrant dance of light that shifts with every movement. In these workshops, the soundscape is dominated by the subtle hiss of the polishing wheel and the occasional adjustment click on the faceting arm. Technicians work in silence, leaning close as they monitor the visual response of each new facet under bright lamps. A trained eye can see when a surface is aligning correctly by observing how it mirrors its opposite facet or how it catches light from the workstation. At this stage, skill often outweighs technology. Software can predict angles, but the human instinct for symmetry remains irreplaceable. Veteran cutters can identify imperfections invisible to untrained observers, adjusting pressure and rotation to coax every possible photon from the gem. The importance of symmetry becomes starkly evident here. If one facet is misaligned, its opposite may fail to reflect light properly. This disrupts the chain of internal reflections that create brilliance, leading to dead zones inside the diamond, areas where light escapes instead of returning to the viewer. Correcting such errors becomes increasingly difficult as the number of facets increases, which is why cutters proceed with near ritualistic caution. They examine the stone under different lighting conditions, rotating it slowly to observe how it responds from various angles. Each adjustment takes time, patience, and a deep understanding of how geometry translates into optical performance. By the time the final star facets and upper girdle facets are added, the diamond is nearly complete in structure. It now holds the architecture that will control its optical personality forever. How it sparkles in daylight, how it glows in soft interior lighting, and how it responds to motion. Though it has yet to reach its full brilliance, the stone already hints at the fire locked within it. What remains is the polishing phase, where those facets are refined into mirrors so perfect that they can bend and return light with razor-sharp clarity. With every facet carved into place, the diamond moves into the phase that finally unleashes its signature glow. Up until now, the surfaces have been shaped but remain dull, carrying the faint haze of microscopic abrasions from the cutting wheel. Polishing is the transformation that turns geometry into performance. This stage doesn't alter the structure, it perfects it. Each facet is refined into a microscopic mirror capable of capturing incoming light, bouncing it around the interior, and sending it back in concentrated flashes. The process may appear delicate, but the precision involved is closer to scientific calibration than simple grinding. This is where the diamond acquires the crisp reflections and sharp scintillation that define its luxury. The stone stays mounted on its dopstick, while the cutter switches from shaping wheels to polishing laps, flat metal discs coated with a fine layer of diamond powder mixed into specialized oils. These laps rotate steadily as the cutter gently presses each facet against the moving surface. Even the slightest excess pressure can distort a facet's plane or round off an edge, so every motion is deliberate and controlled. The goal is to remove only the topmost layer of microscopic roughness, smoothing each surface until it can reflect light with near-perfect fidelity. This gradual refinishing deepens the stone's transparency and strengthens the visual rhythm created by all the earlier engineering. As the polishing progresses, the diamond begins to reveal an entirely new character. The once faint glimmers intensify into sharp bursts of white light, scattered reflections coalesce into structured brilliance. When technicians rotate the stone under a high-intensity lamp, the gem responds with crisp flashes that appear and disappear like tiny electrical sparks. This is the moment where the stone's personality becomes unmistakable. Its fire, its brightness, and its contrast shift into harmony. Skilled polishers read these changes carefully, adjusting the angle or pressure when a facet reflects unevenly. Their trained eyes catch asymmetries that machines often miss, ensuring that light flows cleanly through the gem's architecture. One of the most delicate tasks during polishing is perfecting the girdle, the thin outer rim that encircles the diamond. If it's left too thick, the stone appears bulky; too thin, and it becomes vulnerable to chipping once mounted in jewelry. The polisher must maintain uniform thickness all the way around, preserving structural integrity without sacrificing elegance. This rim becomes the anchor point for all future settings, so its dimensions must align precisely with industry standards. Polishing the girdle requires both patience and experience, as even slight inconsistencies can affect symmetry and optical balance. By the time polishing concludes, the diamond has completed its metamorphosis. The transformation from rough mineral to optical instrument is astonishing. What was once opaque now holds depth and dimension. Every facet is a tiny window engineered to shape and return light with intention. The gem's brilliance, the signature sparkle that has captivated civilizations for centuries, is finally visible. At this stage, the stone no longer looks like something born from volcanic eruption. It looks like something crafted, refined, and perfected by human hands. It is ready for grading, inspection, and eventual placement into a design that will define its future. This phase serves as the emotional crest of the entire journey. After countless steps of analysis, mapping, shaping, and measuring, polishing is the first moment where the diamond truly reveals why it was worth the effort. The gem's personality emerges clearly, and its final destiny as a symbol of status, commitment, or artistry begins to take shape. What's left now is verification, certification, and the finale of its industrial odyssey, where science steps aside and value takes center stage. When the diamond leaves the polishing table, it steps into its final chapter, a transition from object to symbol. The grading process, often conducted in environments that feel more like scientific cleanrooms than jewelry facilities, assigns the stone its identity through the universally recognized 4 C's: cut, color, clarity, and carat weight. Under controlled lighting and precise magnification, experts evaluate the symmetry of its facets, the purity of its crystal structure, and the vibrancy of its optical performance. Every subtle detail, an inclusion deep within the pavilion, a barely perceptible tint of warmth in the body color, or a microscopic asymmetry along the girdle, shapes its classification and ultimately its value. When the evaluation is complete, the diamond receives a certification that becomes its passport, a document that will follow it for the rest of its commercial life. Once graded, the gem leaves the technical realm and enters the world of design. Some stones are mounted into pieces of jewelry intended to capture the imagination: a ring, a pendant, a bracelet crafted to echo the diamond's geometry and amplify its brilliance. Others are stored, traded, or auctioned, becoming assets in global markets where rarity and craftsmanship dictate price. Each polished stone carries a legacy that stretches from geological chaos to human artistry, bridging 2 worlds that rarely touch. The jeweler who sets the diamond often sees only the final beauty, not the engineering risk and coordination behind its transformation. The consumer sees a finished symbol, not a story that spans billions of years. Yet the diamond's final metamorphosis is not merely physical or commercial, it's cultural. Throughout history, these stones have represented everything from strength to purity to eternal commitment. Modern processing lines enhance that symbolism by turning a chaotic mineral into a flawless artifact, proving that even the hardest substances can be shaped by vision and discipline. What began as a rough carbon crystal forged under unimaginable pressure deep inside the earth becomes a beacon of human aspiration. Its brilliance is no longer just a play of physics, it's a reflection of the ingenuity required to reveal it. Standing at the end of this journey, it becomes clear that the diamond's value lies not only in its sparkle, but in the convergence of forces that shaped it. Geological violence, scientific innovation, mechanical precision, and human intuition all converge to create something that appears effortless when finished. But beneath that effortless glow lies an intricate chain of decisions, risks, and craftsmanship, each stage essential, each step a testament to the pursuit of perfection. The diamond's final brilliance is not an accident, it is the culmination of billions of years underground and hundreds of meticulous actions above it. And so, by the time it reaches a display case or rests inside a velvet box, the diamond embodies more than luxury. It carries with it a story that began in darkness and pressure, moved through the hands of engineers and artisans, and ended as a fragment of light captured in solid form. Its path from rough stone to polished gem is a reminder that beauty is rarely born complete. It is crafted layer by layer, cut by cut, decision by decision, until it earns its radiance. The journey inside the diamond processing line reveals not just how gems are made, but how value, meaning, and brilliance are built.